9.6, solving right triangles. To solve a right triangle means to determine all of the 6 missing parts. So you'd have 3 angles, those angle measures, and the 3 sides. Now, one of the angles measures is always going to be a right angle, and you'll know some more information. But in order to do this, we're going to have to learn a new thing, and it's this um, inverse sine. Okay, the inverse sine undoes the sine. So the sine of A equals x. Then the inverse of x equals the measure of angle A. It's going to tell us the degrees of that angle. And we can do the same thing on all of these. On all those cosine and tangent. For example, solve the right triangle. We know one angle, but we need to find these 2 angles. So first, I would solve for B, and you could solve for B in different ways, but I'm going to solve it with the Pythagorean theorem. 8 squared plus 10 squared equals that lowercase b squared. And so we have 64 and 100 equals b squared. So we have to take the square root to get b. Simplifying this down, I know 41 goes into the square root 4 times, right? 4 goes into 16 4 times, with 4 goes in 4 ones. So the square root of 4 times the square root of 41, and the square root of 4 is 2. So that is the length of B simplified. Now, to find the measure of angle A, I can use this information, or I could use this. I'm going to stick to these nice numbers. So the opposite and the adjacent. Opposite and adjacent is the TOA. So the tangent of angle A equals 10 over 8. Well, if I want to know what angle A is, I need to take the inverse tangent. And sometimes that's called arctangent because we don't want you to, this is not an exponent. And sometimes people get confused with that, so they call it the arctangent instead. All right, so I can now put this in my calculator, figure out what 10 divided by 8 is first, and now I'm going to do the inverse tangent. So right now, this is just the regular tangent. My calculator, I have to hit inverse, and then I can hit that. And that tells me 51.3 degrees. Other calculators, you might have to hit a second button. So this inverse button kind of acts as a second. So it's usually written right above your button, your tangent button, on most calculators. So if this is a 51.3 degree angle, to find this angle, I'm just going to say, well, 90 plus this angle has to equal 180. So 180 minus this angle is 90. 90 minus 51.3. I'll just subtract those to find my other angle. So I get 7, 8, and 38.7 degrees. So the measure of angle C equals that. The measure of angle A equals 51.3 degrees. So now I know these 3 angles and these 3 sides. So I had to find 3 things in that problem. Next example, I know this angle, I know this angle. So if I know 2 of the angles, I should be able to find my third angle. So 180 degrees take this 90-degree angle away. That leaves me with 90 degrees for these two. 90 minus 20 is 70 degrees. So the measure of angle S is 70 degrees. Now I have to find these two side lengths, and I'm going to have to use my trigonometric ratios. So I'm going to pick one of these angles. I'm going to pick this 20 degrees. That's my reference angle. If I want to find R, I need to use the hypotenuse. So opposite and hypotenuse. That's the SO sine. The sine of 20 equals my opposite side, R, over my hypotenuse, 15. To find R, I can cross multiply and divide. So I want to find 15 times the sine of 20 degrees. So I'm going to do sine of 20 first. Multiply that by 15. 5.13 is the length of R. And I still need to find S. To find S, I can use this 20-degree angle again, but this time this is my hypotenuse, so my adjacent side and my hypotenuse. So adjacent and hypotenuse, that's cosine. So the cosine of 20 degrees is S over 15. Cross multiply. This is an S, so cross multiply and divide. I want to know what 15 times the cosine of 20 degrees is this time. So 20 degrees cosine times that by 15. I get 14.1. Okay, those are the three missing parts. I had 3 to start. I filled in the other 3. Alright, so now, last example here. During a flight, a hot air balloon is observed by 2 people standing at points A and B. The angle of elevation from point A was 28 degrees. Point A is 1.8 miles from the balloon as measured along the ground. So from here to here was 1.8 miles. What is the height of the balloon? We want to know H. So I know an angle, I know a side. This is my opposite side, and this is my adjacent side. So what ratio does opposite and adjacent? The tangent is opposite over adjacent. So I'm going to say the tangent of my reference angle equals the opposite side over the adjacent side. Put that over 1, so 1.8 times the tangent, cross multiply and divide, 1.8 times the tangent of 28. Tangent of 28 times 1.8 0.957, and that's miles. So remember, this is 1.8. You know, my answer looks like it makes sense. It's always good to check that, especially like on a multiple choice test. Point B is 2.8 miles from point A. So 2.8 miles from point A, that means it's 1 mile, right? 1 mile and 1.8 would make it 2.8 miles apart. Find the angle of elevation for point B. We want to find this angle. So we know H is 0.957. This is 1. This is going to be pretty close to 45 degrees, but we can figure it out. Once again, opposite over adjacent. So the tangent of angle B equals the opposite, 0.957, that side length, over adjacent. So when we want to find an angle, we have to use the inverse tangent of 0.957 divided by 1. So this is the exact answer, so I'm going to just hit inverse tangent. That's going to tell me my angle, 43.7. This angle is going to be a 43.7 degree angle. And just estimating it, I knew these side lengths were pretty close to 1, so it was pretty close to a isosceles, right isosceles triangle, a 45, 45, 90 triangle. There's a homework assignment for 9.6. Okay, a lot of word problems. We're going to really want you to do well because this is a tough topic on the MCA test. So give it your good shot. Ask questions in class. See you then.